All right, welcome back. So we're going to take a look at our last topic, Unit 2, the Rational Zero Theorem. And we're using this Rational Zero Theorem to solve our polynomial functions. So what the Rational Zero Theorem states is that if p of x is a polynomial function of integer coefficients, every rational zero p of x, where p of x is equal to 0, is in the form of p over q, a rational number in its simplest form. P is the factor of a constant term, q is the factor of the leading coefficient term. So if our f of x is this long equation right here, we're looking at just simply the constant at the end. Those factors are p. The leading coefficient at the beginning, those factors are q. So for my factors of p, factors of 40 would be 1, 2, 4, 5, 8, 10, 20, and 40. My factors of q would be 1, 2, 3, and 6. Any possible combination of a p divided by a q could be a possible factor. So for example, we picked out 4 and 3, so 4/3 could be a solution. It's not saying it is a solution. It's just saying if any of the solutions are rational in nature, meaning not imaginary, not involving obnoxious square roots that are not perfect, but they're rational numbers, integers, or fractions, it has to be from these constants in the problem right here. So 4 over 3 is a possibility. 8 over 3 is a possibility. 5 over 6 is a possibility. Any one of those combinations, 1 over 6 is a possibility. Or the integer, like 20 over 1. 20 could be a possibility. But it has to be in the form of p divided by q. So we're going to use this as a way to kind of figure out how to find our solution then. So we're going to be able to list our different possibilities and then use synthetic division to determine which solutions actually do work out. So solution works if the remainder is 0 and only if the remainder is 0. If the remainder is not 0, then it's not a true solution. The goal is to keep on doing this until the polynomial becomes a quadratic. So if we're starting with x cubed, we got to find one working solution to make it a quadratic. If it's x to the 4th, we need 2 working solutions, x to the 5th, 3, and so on. Because once a quadratic, it can either be solved by square rooting it, factoring it if it's a nice number, completing the square quadratic formula if it's not going to be factorable. But once we get to a quadratic, we have known techniques to work with. All right, so now with this first example, I'm going to kind of go through some illustrations of numbers that, won't work and then do work kind of thing, so you can get an idea of what you're supposed to be doing. But on your own, going forward really after example 1, I'm just going to show only the worked out solutions, so we're not wasting too much time here. So we list out our possibilities for p and q. P is 1, 2, 3, 4, 6, 8, 12, and 24. Q is just 1. So our possible solutions are plus or minus 1, 2, 3, 4, 6, 8, 12, and 24, all divided by 1, so they're just those integers. And it's positive or negative. So if it's x cubed, there are 3 working solutions that we can find from this expression right here. So what I'm going to do is, and again, you can choose how you're going to pick and find your solutions on your own, but I'm going to start off with 1. So I'm going to try positive 1. And once I try 1, if it works, great. If it doesn't, I'll try negative 1, and I'll move on from there. So I'm just going to go methodically, starting from the bottom, work my way up. And we go through it, and again, we're trying to get a remainder of 0. If we get a remainder of 0, then it's a solution, so clearly 1 did not work. So then we'll try negative 1. So again, we go through our synthetic division. This is why it's so important for you to be good at synthetic division. Otherwise, these problems will be very, very, very tedious. And we see that negative 1 also does not work. So the 1s are out. So now we got the 2s. So we'll try positive 2 first. Stick with our theme going positive first. And we go through that, and we can see that it got a little bit closer, but it still failed. So we'll try negative 2. And you got to make sure you're careful with your guessing and checking here. Make sure you're clearly copying all the right numbers. Like if I wrote down a positive 5 instead of a negative 5, I'm probably not going to get anything that works, and I'm going to get super frustrated, and then I realize, oh, I should have had a negative. It's going to really mess up the problem there. So make sure you're copying out the correct signs for each of these things. And we can see that negative 2 does work. And we know it works because we got a remainder of 0. So this tells me that this cubic expression right here factored to be x plus 2, because negative 2 was a solution there for the factors of the opposite sign, and then the quadratic x squared minus 7x plus 12. We'd be welcome to continue synthetic division from here, but once we have a quadratic, we can factor it. All our problems will be set up so that if it's a trinomial, it is factorable. And we find it to be x minus 3 and x minus 4. which means my three answers are -2, +3, and +4. This also tells me if I had used synthetic division with 3 or 4 from the very beginning, it would have worked out. It would have given me a different quadratic, but it would have ultimately factored to be the same 3 answers in the end. All right, so there's a little bit of guessing and checking there. Some students will kind of get a little better at this for guessing and checking. Other ones just kind of work at it. And just, as long as you're careful. Typically, if you go through about 8 attempts at synthetic division, you kind of work methodically through the first 4 numbers. If you haven't found something that works by that attempt, you dropped a negative sign somewhere, or you did something wrong with synthetic division. So you got to make sure you're comfortable with the process. If you have to review the 2-3 video for synthetic division, please do so. Now going forward, I already know what the answers are because I have my worked out solutions off to the side here, so I'm only going to start off with worked out solutions and then kind of go at it from there. Now for this one, we'll notice there's a value of 2 in front of the x cubed. So when we work through our p's and q's, p would be 1, 2, 3, 4, 6, and 12. Q would be 1 and 2. So all our possibilities would be all the numbers of p divided by 1, so just the original numbers. But also then all of them divided by 2. So we'd have a half, 2 over 2, 3 over 2, 4 over 2, 6 over 2, and 12 over 2. Some of those fractions are repeats though. 2 over 2 is equal to 1, so we really don't need that. Same thing with 4 over 2, it's equal to 2, 6 over 2 is 3, 12 over 2 is 6. So we have those integers 1, 2, 3, 4, 6, and 12, and then the fractions 1/2 and 3/2. Now, in terms of your guessing and checking, I would recommend starting with the fractions because we know a fraction has to be an answer if there's a coefficient of 2 here. Or at least there's a very, very, very good chance of it being an answer. And there's less of them also. So then, even if it was an answer, I would go through 4 of them and it would just be a little bit quicker than trying to go through all the different integers. And in fact, the fraction that does work is 3/2. And we'll see that when I set up my synthetic division here. So over 2, -9, 1, and 12. Carry down the 2. Since it's a fraction on the outside, you'll find that everything that we'll get will work out nicely. 3/2 times 2 is 3. -6 times -3/2 and give us a -9. That's a -8. That gives us our -12, which is 0, so it worked out. Now, we talked about writing the fraction answer as non-fraction factoring from 2.4, but we are going to write the factor as its fraction, so it's just simply x minus 3/2. And the reason for that is because it's based on now taking out 3/2 from the expression. It leaves us 2x minus 6x minus 8. But we're recognizing that the 2, -6, and -8 all have a 2 in common, so I can take the 2 away from the quadratic expression here, and I can give it to the fraction expression, which gives us a 2x minus 3. Well, so now we factor that quadratic, and that's the other advantage of trying to pick the fraction also. The quadratic will most likely not be an AC method of factoring. It will be a more straightforward. What multiplies to be -4, adds to be -3, -4, and 1, making your life a little bit easier to solve it out. So we're getting 4 and -1 for our other answers. So again, if we had worked through synthetic division with 4 or -1, we would have gotten that to work out as well. All right, so that's our x cubes. We only have to get synthetic division to work correctly once before we get to our quadratic. When it's next to the fourth, we will see we need to have to work through it twice to get to a quadratic. So we have our p is 1, 2, 4, 8, and 16. So our q is just 1, so the only possibilities are plus or minus 1, 2, 4, 8, and 16. All right, so for something like this, I'm going to start off with a positive 2. That's my first answer. So we have 1, -1, -10, 8, and 16. And we'll see that this is going to give us what we're looking for. There we go, give us a remainder of 0. So this now factors as x minus 2 with then x cubed plus x squared minus 8x minus 8. And part of the advantage of kind of starting more in the middle, especially when we have to do synthetic division more than once, is that now my values of p are now based on the 8, which means the 16 is now thrown out. So if I was guessing and checking, now I've got a little bit less options right there. So that's an advantage for that. Our next answer that works is a -1. So we have 1, 1, -8, and -8. Use the new numbers, not the original, otherwise we'll never get to a quadratic. And we get 1, -1, 0, 0, -8, 8, and 0. So then this cubic then further factors as we have the x minus 2 still, then that's x plus 1, and then x squared minus 8. Now, when it's a trinomial, for our class setup, it's going to factor and solve. When it's a binomial, we have to set it equal to 0 to solve that, but that's okay, because we can isolate the x. We square root both sides, and there's our irrational answer. Square root of 8 is really 2 root 2, and it's plus or minus. And then we have the 2 and negative 1 from the synthetic division. Okay, so we're recognizing that it's not going to necessarily be from an x to the fourth, so this could have been from an x cubed. But if you get a binomial expression, an x squared and then a number, you can isolate the x squared and square root it, give you, and this will be, for our purposes at least, the irrational square root answer, and then also the imaginary answer could also show up. And that's what we're going to see in this next example right here. So here again, p is based on 16, so it's still 1, 2, 4, 8, and 16. Q is based on 1 and 3. So for this one, we do our plus or minus. We have our integers 1, 2, 4, 8, and 16. They're all divided by 1. We also then have 1/3, 2/3, 4/3, 8/3, and 16/3. Now, none of those fractions reduce, so we have the equal number of fractions and integers. So again, it's kind of up to you where you want to start. If I start with a -4, though, this one does work, and we're going to see our kind of narrow down our choices for our numbers. So there is an advantage of starting more in the middle. Let's see, it works out for us. So this becomes x plus 4 to go with 3x cubed minus x squared plus 12x minus 4. Now the 8 and 16 factors are thrown out, so we have less choices to worry about. Based on that last one there, and again, using our new numbers, 1/3 is going to work. And again, if you have to come across this as just based on your guessing and checking, you're just kind of going through your process. Do keep in mind, we did talk about how you can solve for the zeros of a function, graphing with 1.4. So if you want to help narrow down and make your lives a lot easier in terms of what numbers should I try, you're more than welcome to just graph these expressions and see what should work. Now, you would still need to show your synthetic division to properly state your correct answer there. You can't just simply say, oh, the answer is going to be whatever we come out with when I finish solving this. But you can use your calculator to kind of see where should I cross the x-axis. And therefore, oh, I'm crossing at -4. Let's try synthetic division with -4. Oh, I'm crossing in between 0 and 1, and my 0 calculation tells me it's 0.3 repeating. Therefore, that's 1/3. Great, then you use that. All right, so again, after taking the 3 out from the 3x, we're in the 12, giving it to the x minus 1/3. We're left with 3x minus 1, and then x squared plus 4. It's a binomial, so again, we can isolate it. Isolating by square rooting both sides gives us an imaginary number now, because it's square root of a negative. Square root of 4 is 2, so it's plus or minus 2i to go with the -4 and the 1/3. All right, so that's our solving with the rational zero theorem. You're using synthetic division to prove a solution works by getting a remainder of 0. Therefore, it's a factor. The resulting piece is what's left over, and then you're solving the resulting part there. As I said there at the end, feel free to use the calculator to help you out as you're doing these problems. So that's it for Unit 2. Next unit, rational functions. We're going to be using a lot of factoring techniques. We're going to be doing a lot of factoring with quadratics, so make sure you're comfortable by factoring quadratics. As always, thank you for watching, and I'll see you next time for that.